I'm Tom Watson. Welcome to EclipseCon 2021. Today I'm going to be giving you a talk about instant on Java cloud applications using checkpoint and restore. So just a little bit about myself. I'm a senior software engineer at IBM in Austin, Texas. I've been involved with open source for most of my career for the past 19 years. I started with the Eclipse project during the 3.0 development when they were moving over to the OSGI specification for their componentization. And we started the Equinox project where we were starting the implementations of the OSGI specification for the Eclipse platform. I'm also involved with a couple of Apache projects, Aries and Felix, and those are also projects involved with implementing the OSGI specification. More recently, most of my time has been spent in Open Liberty, and this is an open source project by IBM that's hosted at GitHub, and I'll go into more details on that project in the talk. I'm also involved with a couple of working groups at Eclipse. As you can imagine, I'm involved with the OSGI working group, which is does the specification work with evolving the OSGI specification. And then I'm also getting involved with the Jakarta working group and the Jakarta specifications. So Open Liberty, like I said, this is a project that IBM hosts at GitHub for an open source project that implements Jakarta EE and microprofile specifications. And it provides a platform for running enterprise Java applications based on Jakarta EE and microprofile. It's highly componentized. It uses the OSGI and Equinox framework underneath to componentize the different parts of Liberty. This won't be a talk about OSGI like many of my past talks, but I did want to mention that because that's what we use to create something called a fit-for-purpose platform. And what that means is you're able to enable just the parts of Liberty that your application needs. For example, if your application only needs JAX-RS, then you would just enable that JAX-RS feature for Liberty, and the rest of the platform doesn't need to be loaded. It's comparably fast for a Jakarta-based platform. We can see sub-second startup times for pretty simple applications. But as I'll go into details in the talk, that may not be fast enough for some scenarios. And in particular, I'm talking about scale to zero scenarios. So what do I mean by scale to zero, and why would you need instant on Java for that? And the basic idea behind it is when you're deploying your applications to the cloud, your application instances may take up resources, and you don't necessarily want to pay for those to stay up and running if you don't have any traffic headed to them. But as your demand increases, you would like to be able to increase those instances and be able to meet the demand of the users. And this is where your startup time becomes important. You want to be able to bring those instances up quickly enough so that the users won't observe any latency or delay when they're interacting with your application. And the general thought is that you need to have your startup time below 200 milliseconds and maybe even ideally below 100 milliseconds. So a few projects out there, for example, Quarkus and Micronaut have looked at using compile to native and using the Graal VM native compiler. So the native compiler is able to compile your Java application down and produce a standalone binary executable. So this executable can be run, and there's no need for an additional Java installation. It's fully self-contained and can run and start up very quickly. And it uses this closed world assumption where during compilation time, it discovers everything that it needs and compiles in all the code paths of your application into that executable. So there's no things available like dynamic loading of additional classes. And there's some limitations on how you use reflection. All that stuff has to be discovered ahead of time at compile so that we can compile in all those code paths to the executable. So some of the obvious pros is that it's much faster. We can see Quarkus applications starting well under 200 milliseconds or even 100 milliseconds. And the closed world allows for a smaller overall code size because we're able to remove all the extra code that you're not using from your application, your third-party libraries, and even the JVM. But there are some cons. You can see lower peak performance, and this can be attributed to the JIT compiler that can be able to optimize your code the longer it runs and find hotspots and make those perform very, very well. There's more costly memory management, and this is attributed to the garbage collector in Java is quite robust and does a very good job. The native one just has to come up to speed to compete and be as efficient. The closed world assumption may not apply to all applications. Ones that heavily rely on reflection may be quite difficult to get your compile time configured correctly. And compile times can also be quite long. They can be up to 2 minutes or more for just a simple application. And then finally, you have this difference between what your development environment and what you're deploying. Most developers are still going to be developing their applications using the full JVM just because that's where their tools are and that's what they're used to for doing debugging and so on. So you're oftentimes going to have to do additional testing to make sure that native executable works. So we've been looking at another approach called checkpoint and restore in user space, or CRIU. And this is a technology in Linux that allows for you to basically freeze dry a process at a specific point in time. And then what CRIU does is it interrogates the process, figures out all the information for it to be able to store down into an image in storage so that it can go ahead and restore that process at a later time and perhaps even on another machine. And that restore is very fast. It's definitely can be under 100 milliseconds to get that process restored and running again. And the process, from its perspective, is just going to look like it went to sleep for an amount of time and then woke up and continued on. To it, it really does look like it never stopped. It continued on. It has all of the objects it had before and so on. So the question is, how fast? And so I thought I would just quickly go into a demo to show what we've been doing in Open Liberty and OpenJ9. So this particular example is using a custom build of Open Liberty, and we've been also working with the OpenJ9 team to get some integration to do a checkpoint. So in Liberty, to start a server, there's this server script, and I'm going to run something called pingperf, which is a server configuration with a very simple application that's just it's a JAX-RS application. So if I start this up, this is just the normal start. It comes up in about 2 seconds. And again, this is really just a hello world example. So if I go here, it'll just do a hello. Then I can stop this. And what we're looking to add is a new instruction called checkpoint. And you give it a point that you want to checkpoint at. And here I'm going to use applications. And so what this does is it brings up the server again, but then at the point where the application has started, it goes ahead and does a checkpoint, and this is where it saved the image off to disk, and then it killed the process. If I start the application again, it's going to continue on right from that point, and it's going to restore it very quickly. So it looks like it was nearly instantaneous, but the reported time you can see down here is 82 milliseconds. So that we can see it's up and running again. If we kill it, it shuts down normally, and it's not working now. And then we can run it again, just restore the same thing, and it'll start that process again right from the point where it was checkpointed. And now it's up and running again. So that's just a quick demo showing that we can in fact checkpoint the Liberty server right after the application started, and then quickly restore it and get it off and running. So the thought is that we would be able to take such a state that we checkpointed the image, and then be able to save that into a Docker image, for example, and then start that Docker image in a container over and over to get new instances of that process running. So let me just, so let's go into a little bit more detail on what's going on here. Like I mentioned, you need to pick a spot where you're going to checkpoint. So that was the @ option. But there's basically two different spots that we're thinking of checkpointing right now in Liberty. And that is, one is right before we run any of your application code, and we call that deployment time. And then the second one is potentially after we've run any of your initial startup code that your application may have. And that's the applications point. So to understand that, we need to kind of go into the overall Liberty startup process. So at the very base of Liberty is something called the kernel. So this is roughly 20 OSGI bundles, and their sole purpose is to provide a platform for installing additional features on. And so that takes about 200 milliseconds to start. Next, we go in and we look and find the configured features that you have enabled and get those started. And that can range from anywhere from 100 milliseconds to up to 200 or 2 seconds plus, like if you're enabling the complete Jakarta EE9 platform, for example. And so that can now, you're either looking at 300 to 2 seconds at this point. And then finally, we're getting into deployment. And this is where we're interrogating the applications, parsing the annotations and all of that. And this is, again, application dependent. If you have a really large application, this can take up to 3 seconds. A smaller one, of course, could take much, much less. And then we get into the application startup code. So these are things like servlet context initializers and early startup stuff from CDI. And this is code that we run from your application, and it has to finish before we report that the application is started and ready to receive requests. So this is completely application dependent. That pingperf example that I did has 0 application startup code. But other things like a Spring Boot application is going to have a very significant amount of startup code. And then finally, after the applications have started, this is where we're going to open the ports and start listening to incoming requests. And so that happens pretty quick, 50 milliseconds or so. So where you need a checkpoint sort of depends on what your application is doing. If your application has very little or no startup code, you can choose to pick the applications point to do your checkpoint. But what's going to determine that is what your startup initialization code is doing. If you're doing something like connecting to a remote database or other things where you don't necessarily want that state saved into your checkpoint, then this would not be a good time to do it, because every time we restore, we would be trying to restore that same exact connection that we had from the checkpoint. And if you're starting this instance up, 10 times, those 10 instances can't share that same exact connection. You really want those things to be established after when you're doing the restore. In that case, you can go back to the deployment checkpoint, and that way we'll do the checkpoint, because everything up to that point in Liberty we know should be safe to checkpoint, and then we just rather than the restore, we'll go directly into the application code. But if you have something like a Spring Boot application, you probably will want to try and analyze some of the startup code there, because that can be very expensive. And perhaps it is able to be checkpointed, and that would give you the greatest gain of startup. So I can give you a quick demo of that. I have a pet clinic server which Pet Clinic is a Spring Boot application that basically exemplar application that they use. And this thing can come up, it takes about 8 seconds or so to come up on my machine. But if we do the checkpoint, and instead of at application, I'll go at deployment. This is going to checkpoint rather quickly because we didn't even get into the Spring Boot code. And so when we run it, it's just going to go directly into that Spring Boot. So we eliminated the overhead of the server to get to Spring Boot, but we still have to run all this Spring Boot code. Instead, if we do at applications, now we're going to be doing the Spring Boot code during checkpoint, and eventually this is going to stop and do the save of the process. There it did. And now if we run Pet Clinic, it's up and running, and you can see it gets started in 130 milliseconds. So drastically faster. So if we go over here, we can just launch it, and Pet Clinic is up and running. So let's go back. So it's, in order to do this safely, you really need to be sure that what you're checkpointing is safe to do it. There's quite a few gotchas that you may encounter. One that we've been looking at is secure random objects. So if you have a secure random object get initialized and seeded during checkpoint, but then reused on the restore side, you could have 10 instances of that checkpoint being restored, and each of those restored instances has the risk that they're going to be getting identical sequential values out of that secure random object. But there's plenty of security algorithms that depend on each instance of your application really getting uniquely sequence of secure random numbers. So you really need to be able to fix those up. So Liberty, we have a number of hooks where we go in and determine if it's safe to checkpoint or not. And then on the restore side, we do a number of things that we fix up. But we're also working with the JVM because the JVM has many things it can do better than us at the Liberty level. And so So what Open Liberty is looking to do is add a new module called Open J9 CRIU. And this is going to provide CRIU support. And so Liberty will call this after we prepared the server for checkpoint, and then we'll ask the VM to checkpoint itself. And during this time, it's going to prepare the JVM to do the checkpoint. So some of the things it's going to do is like suspend all the threads of execution, make sure no code is running, and then it can get an overall view of the heap and what's is in memory at this time. And it can collect up some problematic objects that need to be fixed up on the restore side. So such things as secure random and things like that. And then it also can do other things like optimize the heap, make sure that it's done everything it can to get the garbage out of there, and then get it formatted so that on the restore side, it can get up and running quickly and not have to have any garbage collection pauses. But then after it's done everything that it's going to do, then it's going to call out to the CRIU library in Linux, and that's going to checkpoint the process. And then at that time, it's going to be saved off. The process is going to be saved to disk and then terminate the process. So the idea is that we can incorporate such a thing into a Docker build or a container build, and then each time you can then take that image and store it into into your own container image. And then when you create containers out of the image, it's just going to restore that process and get your application up and running quickly. But there are a number of challenges that we've encountered with dealing with containers. So first and foremost, we need to make sure that the server continues to run as a non-root user. We don't want to have any root processes running in the container. And we're able to do that, but we have to give the CRIU executable some elevated privileges by using some Linux capabilities, or granting it some Linux capabilities. And this allows for it to do all the advanced things it needs to do to interrogate the process, and then also reconstruct the process on the restore side. And even though nothing's running as root, what we found is that the containers themselves, when they're running, need to run in what's called privileged mode. And so this is not something we would recommend you do in production. It's not considered secure to have a whole bunch of privileged containers running out in your cloud. So we need to overcome this, figure out how to get the checkpoint and restore to happen in a container without requiring privileged. The other issue we have is PID1. Typically, when you're running Liberty, at least in a container, we're running as PID1. And this simplifies things because it allows us to handle any incoming signals that's sent to the container to shut down, for example. Then what happens is it forwards that on to PID1 to tell it to shut down, and Liberty can shut down and bring down the container gracefully. But the problem with CRIU is if you're PID1, then what happens is CRIU needs to get itself out of the PID tree in order to checkpoint the actual process. But if the process is PID1, there's no place for it to go. So it just bails out and fails. So we need another process. We've been using something called dumb init in order to make Liberty not be PID1 when we're doing a checkpoint and restore. But once we overcome these challenges, we think that a checkpoint restore has high potential to solve instant Java on needs. It eliminates, we can at least eliminate the cost of the Liberty platform and get into your application code very quickly, and then allow your application to have full benefits of a full JVM running. And then it allows you to keep your development and your deployment runtimes the same. Of course, I mentioned some of the challenges. We need to be able to pick the right place to checkpoint and make sure everything's safe that is checkpointed. And we need to harden our platform, provide the right hooks in Liberty as well as the JVM to be able to prepare and restore safely. And then finally, in the container environment, we need to deal with these privileged container requirements in order to do checkpoint and restore. But yeah, we're excited about this. It's a up and coming project. We're still in the early phase, and we're looking for input from anybody to tell us what they think about this approach. So I'd like to encourage you to evaluate all the sessions at EclipseCon, including this one. And I'd also just like to thank you for coming to my talk. And now I'll be around for any questions. Hello. So there were a few questions that came through. This one right here, are there any plans to make this a JDK enhancement or a JEP in OpenJDK? The answer is there's already one being proposed. It's called CRAC. And the OpenJ9 team is monitoring that and participating at some level. So we'll see where that goes. I believe that one has, it wants to be more general, not just Linux only solution, so that they're basically looking at how they can use probably CRIU on Linux, but also leaving it open to doing it on other platforms. There was a question about, is it possible to take a checkpoint at any time in the run? Certainly with the OpenJ9 APIs, you can programmatically do at any point in your run. But if you did that, it wouldn't go through our Open Liberty hooks. We feel that we need to be able to control exactly when it's happening so that we can prepare the server and the application, everything properly, and give you the flexibility of perhaps you can do it at deployment or after the application initial startup code has happened. So that's our general thinking right now. We may open it up to additional points in time to checkpoint. Some of the challenges are we can't open. It'd be difficult to open it after, for example, you've already opened your ports for incoming requests. I feel that you really want to have that happen in the restore side so that each instance can successfully get those ports opened. There was another question. Is it possible to skip deployment so it only happens on first start? So the way it's happening now is we make it an explicit checkpoint operation. And the reason it's done that way is to try and make it easier to do this while you're doing a container build. So you'll be warming up. In Liberty, you typically configure your server, you do some warm-up processes during the build of your container, and that's doing lots of things to optimize your container, like it's populating the shared classes cache and some of the Liberty caches and stuff. So it makes it quite fast to start up normally. But then after that, we want to have the operation where you can do the checkpoint and you pick, whether you do it at deployment or at applications time. And then whenever the containers start up, we just do the normal Liberty run when you're starting the container normally. So that's sort of the pattern that we're going after. I'm not sure. We could make it automatic where it's just on first run, but it feels like that might be a little bit confusing without some additional parameters. So we chose just to have explicit checkpoint operation. The only other thing I want to mention is everything that I was showing in the demos is built off of a branch of Open Liberty called CRIU, as well as we have a custom build of OpenJ9. So this stuff's not out there in official releases. So if you were needing or wanting to try this out yourself, you would need to build all those. They're both open source, so you can build them, and then you also need to get an installation of CRIU up and running on your Linux machine. I don't see any other questions, but I do want to say thanks. Oh wait, there is another question. There's a question about, is there already a concept integrated into Kubernetes deployments, how to scale down to 0? I don't know for sure. I'm pretty sure that there are ways of scaling down your instances. I don't know the exact mechanics of that though. So there was a question about plain OSGI. We certainly, I've thought about, is there something we can do at the OSGI spec level maybe where we would have some hooks defined there where you can provide your own restore and checkpoint hooks, and so that your services can play into that just like we do in Liberty. In Liberty, they are OSGI services that are doing the checkpoint restore. We can certainly think about doing something at the standard level for that as well. All right. Thanks. That's all the questions.